So I was going to start with what is a side hustle, or what does a side hustle mean to me? To me, I've been side hustling all my life, or all my work, all my digital life. I think I actually started off doing stuff as a sideline rather. I'm sort of building websites for people before it became a job or anything like that. Um, I think a lot of people would say that a side hustle is something that makes you money on the side, but to me, it's just I've been doing voluntary projects for decades, all sorts of things, from building WordPress websites to help people with local shops or whatever, to whatever people need. And it's usually when I happen upon somebody or somebody contacts me for some reason. I don't go out looking for projects, but sometimes projects come in my direction. So this is one of my side hustles at the minute, one of the side projects that I'm working on. Um, and it's a side hustle that has involved lots of some kind of cool things. So that's why I thought it'd be worthwhile maybe talking about it and showing people what it has involved, in order to give other people ideas about what they could maybe do as well. So the point is that this is not my day job. The reason why I do side hustle projects is because it should hold some other interest for me that isn't my day job. The whole point of it, if I was doing my day job in the evening, I would get bored and I wouldn't enjoy it. So this is involved like PHP programming, Laravel, and a few other wee IoT stuff I would never normally touch in work. So that's kind of why it holds an interest for me. And usually I'm doing some sort of voluntary stuff for the projects that are in my side hustles, and that's what makes it interesting. One of the things I will point out to people, maybe, and I suppose it depends on where you are in your career or whatever, but invariably when I go to a job interview, I end up talking about my side hustles, sometimes as much or more than my actual day job. And when I'm interviewing people, I like to hear about other people's side hustles because it gives me an idea. Yeah, usually if somebody's up to stuff voluntarily in the evenings or has some sort of side hustle, it usually says to me that this person has an interest in this stuff, has a passion, and has more things to offer than just doing their job from 9 to 5. So I think it can be a useful thing from a career perspective. What else was I going to mention there? So what is this side hustle? So this side hustle has involved IoT devices and gateways, things like that. PHP Laravel. So back the history of me, I started off as a web designer, then I did web development and ASP and then PHP. And then I started looking after servers and stuff like that and getting more along into the DevOps line. So the development side of things has been mostly alongside my side hustle, rather than my main job, for at least for the past maybe 10 years anyway. It's involved a mobile app using React Native, which Martin, who's on this call, has done completely on its own. It's been absolutely brilliant at pushing that out the door. And I think I'm not really going to touch on the whole mobile app React Native side, because that really should be a presentation by Martin. And Martin did a presentation in React Native a month or two ago. So I'm not stealing any of his thunder at all. He's been absolutely brilliant at getting that out the door, and has done a great job in my opinion. I'm going to touch on a package called Insomnia as well. I'm going to touch on Gitlab, Thingsboard, and Cloudflare. So these are some of the cool aspects, or things that I think are interesting about this project, and I hope that some of these things maybe other people can go, all right, that's a cool thing. If you only pick up on one thing out of this and say, right, I'm going to find out more about that. That's really what I'm hoping for out of this talk, is that you take something away from this, and it might be that you'll try Insomnia or GitLab or something like that. So these are just some of the. I just did a wee word cloud for the crack. The slides are really here just to keep me on track, and I don't mind if anybody wants to jump in and ask a question at any point. I'm quite relaxed about things. Like I say, I don't need you to wait to the end or anything like that. You can just jump in and ask a question anytime you want. So just unmute or whatever. These are some of the things that this project has involved. So if anybody doesn't know what any of those things are, you might want to shout out. But we are going to talk about a few of them. I probably will address almost all of these as I go through. Most of them, just spot one or two that I probably won't talk much about. So, for example, there's one on the board there called LCAR. It's just something I use for backups. Nagios Immunin are things I use for monitoring. And Ops Genie. Confluence, most people have used or have heard of Confluence. It's used for a bit of documentation. And most of the other things I think I will probably go through. I probably won't mention much about Bootstrap, but so the Twitter Bootstrap project is something that makes easy designs easy to use, or HTML template-y type stuff that's easy to use. So that I don't have to spend as much time worrying about that. So food safe system is software for looking after kitchen documentation. So apparently chefs are pretty have a lot of work to do in order to keep records about everything that happens in the kitchen, particularly temperatures of food, so that people don't get food poisoned. So they have to keep good records, and currently most of them do that by paper. And Neil Bradley, who may be on this call, his idea is that this should all be done digitally. The records should be kept in order to free up the time of the people who are working in the kitchen, so that they can get more work done and not spend as much time going in and checking temperatures of individual fridges or individual food dishes. So what that involved then was, actually while I'm here, I might just mention about the history and the versions. So as I set out, maybe about just over a year ago, I started working on this properly, I would say. So I've known Neil for I've known Neil since I was at school, but in terms of food safe stuff, a few years now maybe I've known about it. And there was a version 1, which is when I first met him. I think version 1 was just about to be released. Then there was a version 2, and I think there was some things that maybe didn't work so well in that version. I think version 1 was only iOS only. Version 2, there was some issues with that. I don't really want to talk about those things, but if anybody wants to know more about that, they could ask Neil. So I basically named version 3 as the version that I started working on, because it was, again, the third rewrite, complete rewrite. So I started working on version 3 about a year ago, and I think I actually was a little bit involved in trying to do stuff in version 2, which I'll probably reference a bit later as I go through this. Just didn't have too much to do in version 1. I think I helped a little bit getting into AWS accounts and things like that. So eventually Neil strong-armed me enough into taking over some stuff and doing a little bit more robustly. So this is kind of what it looks like on the web. The web dashboard looks like this for users to come in. So it's basically a lot of CRUD. A lot of CRUD database tables, if you like. So down the left-hand side, you'll see there's things like outlets and kitchens, and there's coolers and deliveries, checklists, and things like that. And a lot of that is just CRUD database stuff. So behind that, there's tables for each of these things. There's database fields, and there's forms that allow you to insert, update, delete, and view each of the individual CRUD tables. So you can see there, for example, on the coolers one, there's a list of coolers, or which is a short word for fridges or freezers. So a lot of these restaurants, butchers or whatever, use fridges or freezers, and this can tell them the temperatures that are being recorded for each of those, when the temperature was last seen, and they can view more details about the cooler, edit it or delete it, or it'll send. They can receive alerts if no temperature readings have been received in a while, or if the temperatures are outside an acceptable range. Get that. So you see down in the bottom right on this page here, I don't know if you can see my cursor, but there's a minimum and max temperatures there. So if a temperature is recorded that's outside those bounds, then an alert will be sent to the user. So I'll talk a little bit more about the alerts maybe a little bit further down here as well. These devices, right? So I suppose the coolers are an intrinsic sort of core to what we're talking about in food safe systems. So these coolers, the sensors, there's little sensors that sit inside the fridges or just outside the fridges. And I meant to have a hunt to see if I could find one. If Neil's on, he might be able to hold one up to the screen and see, but I can't see anything lying around here. But I'm afraid I don't.
Go and move to the office. So don't have any of me.
Oh, good point. I can't see anything around here, but they're if I could describe the size of them, I suppose there's a watch, if anybody can see that. It's about the size of the face of that watch. And they just sit, it looks very like that, except there's no screen on it. It's just a box, a very small box of a fob or a widget. And you basically that sits inside, well, it can sit anywhere. It doesn't have to be inside a fridge or freezer. It could be anywhere in the world, but it records temperatures and humidity and the battery level, things like that. And when these things work over an IoT network, I wonder when was I supposed to talk about IoT? Yeah, actually, I'll pick up on what I'm talking about right now in a few seconds. I'll just go through some more screenshots and then I'll get on to actually talking about the sensors. So basically, there's a screen about delivery. So there's the people in butchers or restaurants or whatever can record source items, the source ingredients that go into producing a particular batch of food, like sausage rolls, and a destination of where that particular batch was sent to, just in terms of for tracing and things like that. Checklists were a big thing now, sort of in the back of my mind. I have loads of things in the back of my head about how these things can be improved. But the important thing to remember as we go through this is that this is a voluntary evening time activity. This is fun stuff, and it's not my day job. I don't have enough time to do this to very high exacting standards. So it's done as best as time allows, really. So, but this particular checklist allows the checklist functionality. It was actually quite complex. I think there's maybe about 4 different database tables to allow people to create checklist templates that people can fill in. They can create a new version of a template and fill those in. So basically, you could have like a cleaning schedule that comes up, that you create once a week or once a month, or there's some of them are only annual checklists that need to be checked. So these forms exist from Food Standards Agency already, these sort of checklist forms. And what we're trying to do is replicate it here so that people can keep them in the central place where they don't have to have reams of paper lying around the kitchen. And the main thing is that they can, the people in the kitchens can produce the documentation when they're asked, when the Food Safety Agency does a surprise visit, that they can show all the temperatures that they've been recording and all the checklists that they've filled in. So yeah, checklist was quite a interesting, heavy one to do, but I do think there's more scope for a form builder. I think we could make something that allows a lot more flexibility, but it would be more complicated to set up. But it's a bit further down the line, I would say. So the tech stack. So this is when I'll start talking about how the sensors fit in with everything else. We're not using cloud stuff. We did version 2 was using AWS as cloud, and the Neil can speak to that about the cost of that. But to me, it seemed like the cost of it would destroy any likelihood of it even getting off the ground. But Neil may have different opinions on that. So I've gone at it for the time being while Neil is building this up to a point where it can hold its own. We're doing it a bit cheaper than we could do on something like AWS. So this is kind of what the tech stack looks like. So I'll probably spend a little bit of time going through this diagram. This is a diagram I created just to try and give Neil a better idea of how everything fits together. So what I'd say is that if we start at the bottom corner here with the sensors, this is basically these LHT65s. Those are the devices that I was talking about that are about the size of a watch face, and they record temperatures. Though they beam out basically the whole point of these things is that they're IoT sensors. They can only send very small, tiny packets of data, and they only do it on they're not constantly connected to Wi-Fi or networks like that. This is a very low powered network that allows very small amounts of packet. And the whole point of that is to maintain the battery life, and that these things will go for 5 years, possibly, without a new battery. So for 5 years, this LHT65 sensor will wake up every 15, 20 minutes. So it wakes up, sends the temperature reading, humidity, whatever, tiny wee packet, sends it, broadcasts it out, and then goes back to sleep for 15 or 20 minutes or half an hour. and then it wakes up again, sends another packet and goes back to sleep. And it uses a radio frequency. Oh, if I can remember the radio frequency, I think it's 868 megahertz or something like that, or hertz maybe. But so it's a very low bandwidth network, but has a very far range. So these sensors can reach out to gateways. So above that sensor here, it sends its data to a LoRaWAN gateway. That gateway can be, up to a kilometer away in some instances, depending on what's in between the sensor and the gateway. But I think Neil can describe how one of them in the middle of Belfast, or one side of Belfast, was actually sending its data to a gateway in the Europa Hotel, which was on the other side of the city centre. So the point is that you need fewer gateways over that will cover a larger area of sensors that will wake up every now and again, send a little bit of data. The gateways pick them up. The gateways are the only thing that needs to be internet connected then. The sensors themselves don't need a Wi-Fi connection or any internet connection. They just send little small packets of data to the gateways. The gateways pick those up. They have an Ethernet connection into like the restaurant's router device or whatever. And they'll send, basically they're programmed then, the gateway's programmed to send those data packets, just relay them on to an IoT platform, which is represented here by that number 4 and that slightly purple square here. So in here, now I don't look after this. This has nothing to do with me at the minute, but I believe, so this is a guy, Mike, who's looked after this and is helping Neil out with this side of it. But I believe that all that's going on here is that he's running ChirpStack, which anyone can download and use. It's open source software. But he's got his own wee sort of basic front end on that called TempWatch. But what goes on in there doesn't matter too much to us, but we could replicate it with ChirpStack. But what happens is that he puts the data that comes in here, he puts it out onto an MQTT queue, which is the MQTT server, could just be part of ChirpStack for all I know. But we have an MQTT address that we can listen to for messages. Is there any questions actually? Because I don't mind people jumping in if I'm going too fast or talking rubbish at any point. But if not, I'll just keep waffling on. Oh, you're muted, Joe. Are you talking? Is there anybody alive? Is there anybody listening?
Yeah, Joe, you just talked there, but you were muted.
Sorry. Sorry, what was the name of the platform that takes the lower events? What's it called again?
This, I've got it written there, ChirpStack. Chirp, like chirp as in like a bird would chirp. Yeah. CHIRP, ChirpStack. There are alternatives. There's a few of them. There's another one I forgot the name of. I think it's the word IoT in it, or IoT network server or something like that. So there are a few of these different ones, but I think Mike's using ChirpStack. And basically, it's a bundle of maybe 4 or 5 different services under one umbrella that's called ChirpStack. And one of the services so it provides a listener or something that will accept the connections from the gateways, and then it will process them or store them or whatever. But it also puts them onto an MQTT queue. So there's an MQTT server in there. It might be I've forgotten the name of the main, Mosquito maybe. It's built into ChirpStack. I don't know what the MQTT server they use is, but it could be something as simple as Mosquito. But basically there's messages there that we can subscribe to. So over here where the number 3 is, then we have, this is basically a Node script, a Node service. So it's written in Node, JavaScript. I was looking over this the other day. I was trying to remember why did we do it in Node? I couldn't quite remember. But then I thought back, and it was actually because in version 2, those guys had started to write some sort of listener that would listen to the MQTT, and they had started writing it in JavaScript and Node. Although I don't think they did it correctly, and what ended up happening was that I ended up writing it for Neil then, and give Neil that code, and that code made its way to the people who were writing version 2. And I don't think they took too kindly to someone else writing the code and pointing out. But I'll show that code later on anyway, because it was interesting and there wasn't a lot of code out there. Some people are protective of their stuff. So basically, this is a node script that just constantly sits and listens and just polls it listens onto this MQTT queue. And if something happens, it will respond to that. So I'll show that code. We'll go down a few slides in a few minutes and I'll show what this does. But basically what it does, a high level view of what it does is it just takes the information from that MQTT queue and sends it into a service called Thingsboard, which is the box 5 here. And I'll show Thingsboard. I'll go into a bit more detail about it later on as well. So these are the things that I think are interesting about this project. The node service that sits and listens, it sends the data to the Thingsboard API. So Thingsboard has an API, and Thingsboard is basically a service to store IoT information and allow different customers to access their own information. And you could have a Thingsboard for a smart city. This is kind of what I wanted to do for Newry, was have a Thingsboard service that was for smart Newry, and you could have all sorts of smart data sensors feeding into this one central source, and you could allow people to access it and build their own dashboards and analyze the data from a smart city. So Thingsboard is another open source project. It's mostly written in Java, I think. Yeah, it's Tomcat and stuff like that. But it's back end. So yeah, it has an IoT rules engine as well. So you can decide whether you want to create alerts based on the IoT data as it's coming in. But basically what all I'm really using that for is because it's an API on front of a Postgres database. And because it is dedicated to IoT, which is what this project is all about. So the data is stored into a Postgres database. That's kind of the technical side of it. You could, if you're taking a higher level view, you could just say, yeah, it goes into Thingsboard and we can forget about it. But that is in a Postgres database. So once this data is coming in like constantly, this MQTT queue is just constantly firing out data because it's receiving from different sensors. Even though the sensors wake up every 15 minutes or 20 minutes, there's always one of them waking up and sending data. So it's a pretty steady stream of data coming in here and going to be saved in here. I'll talk about one of the problems I encountered with Thingsboard too, in case anyone else is using it or plans to use it. So with the data stored in Postgres, Thingsboard, actually, I'll talk about this gourmet side of things down here. So I created a wee mini project. This actually was still while there was a version 2. So this isn't fully integrated into the current version 3, but that's life. So I created a wee mini Laravel app down here for a thing, and I called it Gourmet. But basically all it does is stores information about each of these wee sensor devices. So each of them has serial numbers and MAC addresses and all sorts of wee bits of information about each device. And we want to keep a record we needed to keep a record somewhere of which customer was assigned which device, like where it was located, and some of the access information about each of those sensors, so that the actual web and mobile devices would be able to pull the correct information from Thingsboard. So this is just a wee MySQL database that stores that information. So Neil comes in as an admin. This is a picture of Neil here. And he comes in using the web interface, whatever, stores information in Gourmet, just about, so if a new customer comes along and he deploys 5 new food sensors and a gateway, he can record all that information in here. And then those devices will automatically be added to Thingsboard. There's a script that runs here that does that. I think I need to put that script in there somewhere. Actually, I don't have it recorded there. Should have that in there. So basically, it makes API calls into Thingsboard and creates the devices and gets UUIDs for them and secrets, passwords, whatever needs to be kept about the device, so that anytime we want an interaction from the users over in version 3 on the web interface, then it'll pick the correct device out of Thingsboard. So that's Gourmet, Thingsboard, the Mike's IoT stuff, and the sensors. So up here is basically this top level is version 3 of the web interface of FoodSafe system. So it started off as being web only, and then I talked to Martin. So Martin had never done any React Native before, and I had approached Martin and asked him if he'd be interested in doing a wee side hustle. And thankfully he was, and he has delivered React Native. He just took the bull by the horns and went off and created mobile total mobile interface with a database with offline storage of data. I think it's brilliant what he's done. So, but what happens then is a user, so the user has kitchens and has lots of sensors and lots of information that they want to see of, so into FoodSafe system, and they interact basically with the Laravel app or with the mobile device, which talks to the API. So it's one of two routes in, and that information is all stored in a MySQL database. So if I like the idea of decoupling the sensor readings data from the actual kitchen data. It didn't have to be that way, but I like the idea of that it made things slightly more manageable, broke it up a wee bit. So this database is quite small. It's just got information about each of the users, each of the companies, each of their kitchens, each of their employees, and the names of coolers and things like that, or what their thresholds are for being too warm or too cold. And that's all stored in this database over here. So in the background here, we've got a scheduled job called check cooler temps, and that connects into the database and does a bit of a read and checks. It says, give me back all the latest temperatures for all those, every device, and tell me if it's within the thresholds, or if the battery's low, or if we haven't had a reading in more than a couple of hours, then let us know about it. And what check cooler temps does then, that script will notify the end user, the customer, the person who owns the cooler, the kitchen, the restaurant. And it can notify them by using Twilio's API. It can notify them by WhatsApp or with an SMS message, or by email, and we use AWS's, I have SMS in there, it should be SES. And also there's an interface into the Slack API as well that notifies Neil as the admin. So we've got a Slack, what do you call it? Slack workspace for FoodSafe, and Neil as the admin will receive messages in there to know that sort of notifies him if there's been any devices that need attention, so that he's on the ball, and it's not just the customers receiving this stuff. Down the bottom corner, I suppose, a few other components in there, 7, 8, and 9. So we use GitLab for deploys. I'll talk about that in a second, just for the code and deploys. There's some Google Analytics in there. I don't even look at that, so I think Neil maybe looks at that, but it's there. And data analytics for the future, what I would want to do is use a thing called Metabase to allow Neil to query in to the data and database. So we could actually have Metabase have a view of each of the databases, so the Postgres one, the MySQL one, and maybe other sources as well, and be able to join across those and create reports and stuff, rather than having to come directly to me or somebody else and ask for CSV dump or something like that. So that's a little down the road. I've been meaning to do that for a while, but I haven't had the time to get that set up. So that's any questions at this point before I move on from this screen? No? Is this interesting or boring?
Very thorough explanation, Johnny. Thank you.
Cheers, Magic.
I've got a question for this one.
Oh, it would have to be you, wouldn't it? Like,
Yeah.
it's going to be a hard question too.
No. What protocol are you using to put things into Thingsboard? Because it has HTTP and
it's just a
MQTT.
HTTP. Yeah, I'm using the HTTP API endpoints.
So could you go direct into from the MQTT?
I don't even open the MQTT port to the world. I haven't even investigated for puts using MQTT as an input. I haven't checked that.
So you're subscribing and then publishing, kind of.
Yeah, but I'm not publishing to MQTT. I'm publishing using the HTTP endpoints.
Right. Yeah.
In Thingsboard, and I suppose it has published endpoints for adding data into its database, but I was using very similar endpoints to create new devices. There was something else I was doing as well in this gourmet script down here. These scripts do stuff to using the HTTP endpoints. maybe like assigning devices to customers or something like that is done in there as well. So I'm using maybe 3 or 4 different API endpoints, and it was easy.
Yep.
I just needed to generate a token or whatever it was and make my HTTP request with that token. So yeah, it's not extensive. It doesn't make extensive use of MQTTs. We're just listening off of a MQTT queue and making use of that data. And it means that we don't have to get involved in section 4 unless we're in that box 4 unless we really wanted to or wanted to replace that with our own setup of chirp stack or whatever. But that's not really on the cards at the minute. Plus, Mike's service is pretty robust and reliable, in my opinion. Right, so just jump in and shout out. I hope I answered Mark's question well enough there, but
Yep.
If anybody else, just shout out if you have any questions. So
Johnny,
there's a lot of things in. Yeah, sorry. Yeah.
Johnny, a question. Just so where is this all running?
Oh yeah, good point. Right, that is a good point, and I actually will show a little bit of that. For years, I've been running my own servers, looking after my own bare metal servers. So I just hire servers from companies that lease servers, and I've been doing that for 15 years or more. And I started with one-on-one. Actually, there was probably somebody else before that, but I was using one-on-one. And at the minute, I'm using Scaleway and OVH. So I have a couple of American companies as well for small VPSs. So I've got servers maybe with 3 to 4 different companies at the minute, and I have console access to those servers. So I'll actually, yeah. So that question has led me straight on, Joe, to that exact thing. So basically I've got bare metal access, console access to a bare metal server. And this particular one here, Prox002, I've called it, is in, well, I had 2 in Amsterdam, one of them died. I had 2 in Amsterdam with Scaleway. One of those, the disk drive died on it, so recently moved a second server to with OVH, which is another massively huge company that provides bare metal servers and virtual servers and stuff like that. So this, what I do is install a thing called Proxmox onto those servers. And Proxmox is basically like VMware. So people have probably heard of VMware, and I don't really like using proprietary software very much. Proxmox is open source virtualization management software. So rather than having to manage all the virtual machines on the command line, it gives you a bit of a web interface to do this the same way as you might have with VMware and things like that. So this one's maybe running just 2 servers. They're basically a Thingsboard server and an application server. And it's solid. It's pretty solid. It's cheaper than AWS, and I know what the cost will be every single month. I won't get a surprising month of being charged $400, which is things like that have happened to Neil, and I think there was a few months where we were kind of panicking and saying, Jesus, how do we reduce the costs here? And there was a few different things that happened. So the guys who did version 2 had hugely over provisioned the database server and given it a huge amount of resources that I didn't think it warranted it whatsoever. So we ended up scaling that away down to try and save costs. We did a few other things that they were doing backups, and there was all sorts of high availability on those databases. There was things that weren't needed. So I know what the cost of this will be every month, and I like being able to budget that and knowing exactly, right, this isn't going to cost us any more than X amount of pounds every month. So in my view, it's cheaper than that. It does not give you the same level of flexibility that you would have with AWS. So if funds weren't a problem, I would be using AWS. I would be having all the databases in RDS. But at the moment, so once we get onto a good trajectory where we're making a decent amount of money from all the customers that we have, so we basically need to unload a lot more customers to get it to the point where we can afford to put this into RDS and run it there and have less headaches, basically. But the lockdown has sort of hugely affected these restaurants. All the people who would be customers of Food Safe System have been hit by the COVID lockdown. So it's been a struggle, I suppose. We might have expected things to have picked up a bit more by now, but I think once we get these vaccines out, I think things will we'll be having a different talk this time next year. It'll be all in AWS, hopefully. So we don't have the reliability and the flexibility that we would with AWS, but it is cheaper, and I know what the costs are going to be each month. Does that answer your question, Joe? So I suppose I'm using a couple of different companies: OVH, Scaleway, and then a couple of smaller companies. I can't remember the names of all of them online. Server Rika is one of them that I use as a backup server. So it's got like 4 terabytes of storage or something like that, and it's sitting in Montreal. And so I basically it's with a completely different provider, so I know that, right? Even if one of my hosts' whole data center burns down, then I know that I've got in a different continent, I've got a backup of that data that I need to get back up and running. Is that answered okay, Joe? Okay, so we store the code is stored in Git, Git repo, and we're using Gitlab to store the data because they allow unlimited private repos. GitHub didn't at that. When you go back a bit, they didn't allow private repos as far as I'm trying to remember the history, but I can't remember exactly when things happened. So I like GitLab better anyway. And so we just try to create branches, create merge requests. I suppose I'm mostly the sole developer on the PHP side, but I do also like to try and get, if I can, to get Martin and Sarah to look at my merge requests. I would like to get into the habit where we've got oversight and people viewing into what I'm doing, so people get a better idea of what's going on. We have a GitLab CI YAML file that's part of the part of the project. That GitLab CI YAML file defines, I'm going to show it now in a second, and it defines how the code is deployed. And the code is deployed onto a GitLab Runner. So the servers that I was talking about up here, this server, say app 003, it has a software called GitLab Runner running on it. And that each of those GitLab runners, each of those servers can be targeted by the GitLab CI YAML. Before somebody asks about containers and stuff like that, we haven't got this containerized yet. It wouldn't actually take too much work to do that, but this is a side hustle, and don't have time to do every nice wee thing that I would like to do. So the code is in the Git. Let's see if I can, right. So here's the GitLab CI files. I've tried to blank out anything that could be misused by, what was that guy that was on the last time? Somebody or Fartwhacker or something?
Turd Sandwich was on.
Turd Sandwich. I just wanted to make sure that I had everything blocked out so that Turd Sandwich couldn't hack his way into Food Safe System. There's my daughter. Oh, here, take the dog out. Get out. Sorry. Daughter likes to offload the dog onto me. Right. So in GitLab, basically when we merge to master, or when an event happens in a Git repo with GitLab, the GitLab CI.yaml file is read, and this is an example of the YAML file. So I've got 2 stages in this, or well, 1 stage, but 2 steps, 2 tasks in this particular deploy or pipeline. And you would have your tests. You should have your tests running in here, testing that everything's okay before it deploys out. But again, don't have a huge amount of time to devote to doing things. I guess it's really more getting as much stuff done as quickly as possible out to the customers, and quality will have to come a bit later on. So basically the script section is what is run. So this, for example, for this deploy to the dev server, the rule for this step is that if the branch that you're committing to is the branch named dev, then this stage will run, and it will run whatever scripts are specified in the script section. What the script section does is just does a git pull from the dev branch down onto the dev server, runs composer install to get any libraries that it needs, any vendor libraries, and then it'll do a PHP artisan migrate, so any database migrations that are needed, and basically that's it then deployed. That's the new code will have been deployed at that point. So the tags then in this section here, line 14, that defines which server this is deployed out onto, or the stage will run on. So it's looking for a Gitlab runner with the name of dev. It's probably foodsafesystem.com if anybody wants to try to hack into that, I suppose. That's probably what's been hidden there. And then if we're deploying to production, it'll be, I can't sort of be able to move down there, but it'll have a different tag. So it'll deploy it to the production server, and it only runs according to these rules. So the rules are if it's the master branch, or if I've deployed via the web or API, then it will run the scripts on the production server that it'll pull. Do get pulled from the master branch, run composer, run PHP artisan, migrate, and then we'll have the new version of that code will be live on that server. I think that's really easy to get up and running. The Gitlab Runner software itself is, in terms of installing that, takes a few seconds. It's nothing major, and all you need to do with that is supply it with a token that you receive on your Gitlab UI panel, so that it knows that that Gitlab Runner belongs to you. They also have shared Gitlab Runners, so if you wanted to run code or deploys or builds or tests on the Gitlab owned servers, their shared servers, then you can do that as well. But I'm running where I'm running here where I know the environment. So, is there any questions about the Gitlab stuff before I talk about the next cool wee thing?
Johnny, you said that you were on GitLab because GitHub didn't have free private repos at the time.
I can't remember when they brought them in. I just like GitLab better now. Anyway, well, you know what? I remember now what it was. Didn't Microsoft buy GitHub?
Mm-hmm.
That might have been it. That might have been enough to push me.
I'm a big fan of GitLab. I've just started using GitHub for work, and I just wasn't sure if you were doing it on philosophical arguments, like, you know, GitLab is free software, I guess. I just was curious about that choice. You kind of mentioned it, but
so in terms of history with GitLab, I worked in Queens. I can't remember how long ago this was, maybe 6 years ago. I suppose GitLab was fairly young back then, but at that time in Queens, the computing department weren't using Git at all. Their students were still using SVN, and they were still teaching them about SVN or some other older tool. And I was pushing. I thought that these kids needed to learn about Git and the modern things that people were using in the industry. So at that time, I set up a GitLab server. So that probably is part of it as well, because it was already open source software. I was able to deploy that in the Queen's Computing Department and run it for, I can't remember how many students. We had a few thousand students in Queen's. I was able to run that, and I was able to actually, that's what I really liked about it, was that I could communicate with GitLab via its API as well. So I had scripts that would run that would generate the user accounts or generate the project repos, do all that management stuff that I didn't really want to have to deal with, automate all of that via the GitLab API. So it's probably that history, and I suppose maybe a distrust of Microsoft at that time. Now, I suppose proven themselves to be fairly decent guardians for the past few years. But it's probably things like that tainted my view a little bit towards GitLab as opposed to GitHub. But I really don't care. They're tools. Obviously, I prefer things that are freely licensed. Does that answer your questions? Yeah. So the next thing I really was going to talk about was this Node script. So wrote this maybe back December a year ago, that was just before lockdown. And this was, there was some sort of Node script that the guys who wrote version 2 had been using, but it didn't work right. There was a few things wrong with it. So I started writing this version here. So I don't know how clear this is on your screens, but this is the crux of the code. It's very simple. There's very little to it. Basically, it just does it connects to the MQTT server address. So behind this, what you aren't seeing here is there's a config file here, the config.js or whatever, that has the addresses and passwords for the MQTT and the MySQL databases and Thingsboard and things like that. So basically, it just connects. Oh, well, let me see. Right. Oh, there's the other thing. This is on GitHub. This on GitHub. So if you were to do a search for LHT65, whatever, you could get this code. And I put it out there because there wasn't much information about how to parse the data that comes from an LHT65. So I'm hoping that this would help someone else. The guy, Mike, who we were talking about earlier, did have code that does this, but he didn't want to share it. So I had to write this myself. What I'll point out, I'll skip on a section just to show you, and I'll go back to that screen that was on there a second ago. So just this bit highlighted in green here. This shows you, this top section of this lower screenshot shows the feed that comes from MQTT. So I'm receiving a data packet here, received application ID 9. There's all these fields. We're seeing that this particular sensor is called FoodSafeTH83. It came via a gateway that was called FoodSafe Gateway 11, and there's lots of other information there. All that information isn't really important to us, except for the bit that's highlighted in green. That is the data packet, and you can see there it's labeled data, whatever. It's 16 characters, and it's encoded in base 64. Inside that, I think this is what's really cool about these LoRaWAN devices. It's cool, and it's also very frustrating. But you have 16 digits there, encoded in base 64. That inside that there's two temperatures recorded: the internal temperature of the sensor, plus the temperature if you connect an external probe to the sensor. So there's two temperatures in there: a humidity reading, a battery status, whether the battery's okay or not, and also battery voltage, all in that wee small string of 16 characters. The challenge then is converting that from base 64 and getting out the lower bit here. So you can see here that I'm in my log, I'm outputting. So that actual data packet there, YWB4, blah, blah, it actually, when after conversion, it relates to the temperature of this freezer was minus 18.46. The external temperature, I'll mention that in a wee minute. That's not a real temperature because that's less than absolute zero. Humidity is 80. Battery status is okay, and battery voltage is 2.822. And that is all stored, all that information is stored in that 16-digit string. I think that's kind of cool, but frustrating because it takes this code and a wee bit of hacking around to try and get the right information out of it. So basically, Johnny, sorry, yeah.
Is that the max amount of data that's possible?
I think roughly it is. I think if they had been able to fit it, I think it is 16, but don't quote me on that. We'd have to go looking on LoRaWAN and see. It could possibly depend. I was looking at Sigfox at one point a few years ago, and I did used to know the maximum packet size on Sigfox, and I'm assuming Sigfox is using LoRa as well, but that's gone out of my head now. I have no idea. But I'm assuming it's 16 because I think if they had been able to fit any more information in there, they probably would.
Yeah.
About that. So if you're recording a lot of devices, like Neil wants to put in mouse traps, and all that's really needed for a mouse trap is true or false, whether the door has been triggered or not. So a lot of that, the data would be redundant on that. We just need to pull out the first character probably, and then convert it to the Boolean or whatever. So some devices won't need all of those fields, but this particular sensor is using all of those fields. I had to go, you'll see here that it parses right up to the 16th or whatever digit. So the code here, what it does then is takes the code in its base 64, converts it to hex first. So that's a step you have to do. You have to convert from 64 to hex. And then you cut out a slice between digit, in the hex version, between digit 4 and 8 is a hex value, and that is the temperature in hex. So you take out digits 4 to 8 and then parse that as an integer, and you will then have the temperature, or a number, basically. So if the temperature is above 125 Celsius, then that just on the LHT65s, that represents a negative temperature. So because it doesn't have minus values, they just record a negative value as just a really high number or some shit. So I can't even, like, I got mad into this. Like, this was doing my head in for the best part of a day, trying to go through this one day. Now, I was working at First Derivatives at the time, and I was bored, so I just went ahead and did this while I was sitting there one day. So so if it's a really high number, more than 125, then you need to subtract 65,536, because why not? To get the correct negative value. So if it's a high number, then you minus that away. So that's what I do here, is check that, take away the 65,000, divided by 100 or whatever, and then I've got the internal temperature converted to a decimal. So I'll get minus 18 if it's a freezer, whatever that is. Then the same for the external temperature then, but the external temperature is between digits, on the hex version is between digits 14 and 18. Pull them out, pull the hex out, convert it to an int, check that the temperature is above 125, and if it is, take away 65,000 and divide by 100, and you'll get the external temperature. The humidities, so the temperatures are the ones that were probably the most complicated. The humidity is simple enough. You just take out digits 8 to 12 and take out, it was divided by 10 or whatever to get it as a decimal. And we've got our humidity in between 0 to 100 or whatever. The battery status and then the battery voltage, or they're just different blocks in that big long hex string. You're just pulling out each between certain characters and another character. That will give you a number for that value. So what have I got here on my summary screen? So I've put this code on GitHub if anybody did want to have a look at it. It uses Node, so you just run it. Just run it Node, and then pass it the name of the file with the JS extension, and it runs, and it'll just sit listening to an MQTT queue. I think what do I do with mine? I'm trying to remember. I can't remember how I decide if it's one of our customers or not. Oh, there's code later on that does that. Checks against the database to see if it's one of our customers or not. So it could be somebody else's sense, and it's nothing to do with us. So we'll check that, and then if it is one of our customers, I put the information into Thingsboard. So database 64 encoded, convert text, pull out the characters, blah blah, convert hex to integer, check if the temperature is negative. Yeah, so that's more or less what happens. That was one of the more interesting tasks of the project, was doing that. And there's a good point here. Step 3, system D versus PM2. The guys this was another one of the problems we had. Every few weeks, the AWS server for version 2 would crash, and there was a couple of. Well, it crashed it was for a different reason, actually. It crashed, but there was other problems. The resource utilization was ridiculous. They were using this thing called PM2 to manage the Node application, and the settings they had in it was for a web service that was going to be pummeled. And so they were starting up a few hundred child processes that were using up a lot of memory and stuff. It was just pointless for something that didn't really need it. So I got rid, once version 2 went out the window, I just replaced it with a system D process. So the guys started using my script, but then if there was something wrong with it, if something went wrong, then they said, well, we didn't write that code, so it's not our fault. And I would basically then have to go and troubleshoot and find out that the problem was their code and give them the exact line in their code of where the problem was. I think things just started to get a bit tense then. Because they didn't really want to fix their own bugs that they created. So this is the top bit here is just a very simple systemd that runs. So you can see there it just uses Node and runs the JavaScript file because it uses the config file and listens to a queue like this and takes the data and puts it into Thingsboard. So Thingsboard is anybody can install this. It's freely licensed software as well, and it allows people. So you could have devices in your house. Thingsboard might be a bit overkill for if you're only doing a few things around the house, but you can feed lots of inputs, lots of devices, lots of readings into Thingsboard and as a central store for all this sort of data. You can divide out devices by customers, by asset locations. There's an awful lot this can do that I barely scratched the surface of it. And there's a slight learning curve, I suppose, to get up and running with it. That I probably wouldn't want to have to do some of that stuff again. There's like these rule chains. There's a wee bit of learning on that. I should probably document that again. I'm not sure. I need to go back and check the documentation of that, but it would be worthwhile me checking that and making sure that, because I don't really want to have to redo all of that. But basically what you can end up with, you can create dashboards for people. You can have world maps here that show heat zones or whatever. But I don't really care about that, because all I really wanted was a data store with an API that I could put that in and take data out. There's the dog back. So it's an IoT platform. It's got an API, it's got dashboards, and you can manage the rules of it. Some of the drawbacks, yeah. So the events table is a problem in my view. So there's a table in the Postgres database that gets populated for every event that happens with Thingsboard. So like an audit, it's basically an audit table. It has no relationships to any other tables. There's no foreign keys or anything like that. But I started to panic at one point, saying, why the, oh shit, look at the size of our Postgres database. It's 30 gigabytes in size. And so I sort of dug a bit deeper for a few hours one night and realized that the majority of the data was in this table called events table. I went and did some more digging around the forums and realized that this data isn't particularly important. It's audit information. It certainly wasn't important to what we were doing in FoodSafe. So what I did then was create a function that would drop all old data from the events table every now and again, just to keep things fresh. And once I had dropped the event table, the data that was coming actually from a few hundred devices, a few hundred sensors. It was maybe, I think it's like maybe 2 gigs at the most at the minute of event data for the last year from maybe 100, 200 devices, something like that. So the data doesn't need to be huge. But that was something to learn, because backing up that database then, once it was 30 gigabytes, with 30 gigabytes, that's fair enough, like it's not that big. But the problem is that if you want to make a backup of that, Monday, Tuesday, Wednesday, Thursday, Friday, or whatever, that multiplies by 7. And then if you want to have weeklies and monthlies and things like that, you're talking the amount of data builds up very quickly. The Thingsboard does have frequent releases, and they keep putting more features in. So it's a challenge to keep it updated. I think I spent at least one weekend upgrading it through lots of different steps to get it up to a more recent version. And I think I'm more than overdue to do that again. But again, it's time, which I don't like to admit, because it could be a security hole. And it's a lot more than we need for this particular project. We could just store all this data in any other database. Now, it's being stored in Postgres, which is a relational database. Now, personally, I think this would be much better in a time series database. It'd be more efficient because every query that's made on the data is based on time. I'm trying to think of the names of some of the time series databases. It's escaping me right now. The dog's annoying me. All right. Like Influx or something like that, as a time series database would probably be a better option if you're starting from scratch. But I'm happy enough with the Postgres stuff, and it could be scaled out if and when we need to. This is what some of the Thingsboard interface looks like. So for each device, if I go in here to, this is how we're naming the devices: FSSLHT65, and then a code name for the customer. And we can see here, if you click on latest telemetry, you'll see that these are the temperatures that are coming in. We've given them, these are the field names that I've given myself: internal temp, external temp. We just created those. So there's no rigid schema as such. There's the data in here, and then the temperature that was received. So the -327 external temperature, that just means that the external temperature sensor isn't connected. So that's like the lowest figure that it can store, or whatever, something like that. So it's well below absolute zero, so it's obviously nonsense. And when we receive a temperature of -327, we just say, right, that device isn't connected. So that's what Thingsboard looks like. I've mentioned the event data, the event table, and yes, so like one of the things I did was create this function. So I found this online. I'm not good enough with sort of SQL to do all this stuff, but there's a wee function in there called UUID timestamp, because you can see on the this is dbeaver, dbeaver, call it database tool, and I'm looking here at the data that's in the Postgres database. And you can see the TS field, timestamp field, is it's basically a Unix timestamp, but to the millisecond. So normally you would get a Unix timestamp, it would be to the second. But Thingsboard uses it to the millisecond for accuracy, I'm assuming. So it means that you've got to convert, we've got to divide by 1,000. If you want it in a normal sort of time, you're sort of dividing by 1,000 and then converting it to a normal timestamp, which is what this function does over here. So when I was dropping old entries, I was using this UUID timestamp function that allows me to drop everything older than 30 days. It's a bit easier to use. And then if I'm querying the database, I'm using that function as well. So here I'm doing select whatever from key values. And I'm using the to timestamp function to take the timestamp field and divide it by 1,000 and convert it to something that I can read. So these temperatures readings were from the 27th of December at 4 in the morning. And it just allows me, it's much easier to see that than trying to convert a Unix timestamp in the head. So I do PG dumps on the database as well. And when I'm dumping for backups, I'm excluding the event table because it's the big one that holds information that is of no real value to us, just in our use case. We use some external services for notifications. So we're using Twilio to send SMSs and WhatsApp. We're using AWS to send emails. And there's very little code was required to get this up and running, which was great. Just using some tokens that I generated from when I was using Twilio. Actually, the hardest part of this whole Twilio bit, because Laravel had a Twilio client, which made it that bit easier to interact with Twilio. But the hardest part of that process was getting verified, or the OK, from Facebook to allow us to send WhatsApp messages. So there's very strict rules on contacting customers by WhatsApp, because Facebook don't want it to turn into a spamming machine, I suppose. So we spent a week or two, and you don't get to talk to anybody or communicate to someone. You just get to send messages, and then they'll tell you whether it's okay or not, and it's just a yes or no. So it was just a no, and then a no. A few days later, I changed. So basically, this WhatsApp message variable down here, cooler alert, cooler name message, manager notifications, or whatever. I went through, maybe 10 different variations of this message until they went, yes, that's okay, and we were allowed then to send messages to our customers via WhatsApp. And that's just, I suppose, they're protecting the customers from spams, but made it difficult for us. But there was a wee bit of the codes. There's very little code to do that. It was pretty cool that we could just. So basically, on our checks, we're checking the temperatures of all the devices. If a customer has elected to be notified, and an alert is due, the temperature is outside of the thresholds, then we send them a Twilio message to their mobile phone number, or an SMS if they've requested that, and or an email if they've requested that. But the emails go via AWS SES. Oh, and then we have Slack notifications as well. So that's what the Slack notifications look like. Again, this was what I said, 20 lines of PHP. It was just basically a curl to the Slack endpoint. And again, on that same script that checks the temperatures of everything, it'll just fire off a message to Slack. And that's only seen by the back office, like Neil. You can see what's going on with each customer. So in this one here, for example, you can see there's some customer that's their OTS upright fridge has a temperature that's slightly above 10. It's up to Neil whether he acts on that. I'm assuming he don't really act on that. They might have had the temperature of the fridge door open for a while as they're doing their work. But once that starts getting for a long period of time, Neil might Neil might pick up the phone and ring them and say, look, do you guys realize your fridge temperature has been quite high for the past couple of hours? And Neil can tell you as well that a local butcher's in Newry, one of his freezers died one night, and he was receiving messages and he basically went down, the freezer had died, and he had to move all the stock from that freezer into another freezer, but it saved a few £1,000s worth of stock from perishing. So it's a simple thing. Neil can just have Slack open and receive notifications about what's important. Recently moved the domain onto Cloudflare. I'm trying to use it to give us a bit of flexibility, a little bit of protection, but we're on the free plan. We're not paying for anything yet. I think as a startup, it's nice to have these free services, and as you become more successful, then you can choose to opt into to have more protection. So yeah, I think it says there was a few threats blocked or whatever, so they've probably blocked some bad robots or bad bots or possibly denial of service or something. Well, probably not a denial of service, only 21, but so yeah, you get a bit of a performance boost because you're using the Cloudflare Edge services if stuff is cached there locally. You're hiding your IP address behind Cloudflare, and but flexibility to flip the server if something goes wrong, if we want to bounce it onto a different backend server. The other cool thing that I've been using for the past while is Insomnia. Now this could probably be a meetup in itself for anybody who's interested in REST APIs. So if you're just down in the bridge bar and you're having the crack, just ask around you and see how many people are really enthusiastic about REST APIs. Most people are probably using Postman as their REST API client for testing things. I forced Martin to use Insomnia as his REST API client, and I think he's now a convert, and he can't understand how Postman works either now.
I don't know. Everyone in my work uses Postman, and I just use Insomnia. I don't know how to work it. It's too much rubbish.
Yeah, I kind of feel the same now. Once you've used one, it would be hard to use another one. I suppose that's what they rely on. But Insomnia is freely licensed software, so I'm more prone to want to use that. I do have to get my organization together in terms of workspaces. So you can have workspaces and environments. So for example, I could have a Gitlab workspace, I could have a Thingsboard workspace, I could have a food safe system workspace, and I could have local environment variables for each of those, so passwords and tokens for access and different things. So it allows you to organize your API endpoints in whatever way you really want to. Workspaces. So you can see here, for example, so anything highlighted in purple here just comes from an environment variable. You've just go into environment and you can specify. So it allows me to switch between dev, production, or local very easily by just switching environment. But the thing that was bugging me and that I needed to overcome was if I wanted to pull an API endpoint that required a token, that's basically two API calls. And I was then having to paste the token into the environment so that the environment had the token, so that when I went to do the next API call, it would have that token. That began to annoy me, and as I was saying to Martin one day, like it'll annoy me it'll annoy me a little bit, and eventually someday I'll flip and just say, right, I'm going to sort this out. So there is something in Insomnia that allows you to manage that, and I think I opened. I don't know if anybody can see. Can anybody see my web browser now? Hopefully, but on Stack Overflow,
yep.
I suppose I could post that in the chat. But is there a chat here? But basically, this post here is brilliant, and this has allowed me to when I can just go straight to my API call, and in the background it will call another API call that gets the token, and it will use that token then within the first API call. So it's like chaining two API calls. So I don't have to worry about getting the token and putting it into the environment, and that token will expire after a certain amount of time. This allows me to chain it all together. And I don't think that is particularly well documented anywhere, but I find that the Stack Overflow question really helps. How do you get to chat? I'm posting this mainly for Martin because I told him I would work out how to do that. So I need to go back to Firefox, and if I go to I suppose Insomnia's party. What time is it? Jesus, have I been talking for an hour?
Insomnia,
Lord, Insomnia.
9:45.
Yeah. Well, I'm finished. End the slides. Begin the questions. So, if anybody, that's basically all I really had to say. So it's hopefully there's something in there in all the things I've said that other people can pick up on and go and use and help them with, or even just start a side hustle, have a wee side project that gives you something to do in the evenings, and also you can use in interviews or whatever, or just for the satisfaction of doing something good.